Brady Electronics estimates that it will sell N units of a new toy after spending X thousands of dollars on advertising, where N sub t is given by the following function. We're asked to find the relative extrema and sketch a graph of the function. Well, to find relative extrema, we need to begin by finding critical points, because any relative extrema, which means any relative maximums or relative minimums, are going to occur at critical points. To find the critical points, we need to find the first derivative. So taking the derivative of n of x, so we're finding n prime of x, the derivative of that function is given by a negative 2x plus 300. Critical points occur where the derivative is either equal to 0 or where the derivative is not defined. Since the derivative is a polynomial function, it's defined for all real x values. So we're going to set the derivative equal to 0 to find any critical values. So setting the first derivative to 0, we're setting a negative 2x plus 300 equal to 0 and then solving for x. So subtract 300 from both sides and then divide both sides by a negative 2. So we get x equal to 150 as our critical value. So now to determine whether the critical value is a relative extrema, we need to break the x-axis into two intervals around that critical value. So we're dividing the number line, the x-axis, into the two intervals negative infinity to 150 and then 150 to infinity. And what we want to determine is what is happening to the derivative on either side of this critical value. So we're going to perform the first derivative test to determine the sign of the derivative in each of these intervals. So we're going to pick a test value in each interval. So from negative infinity to 150, a good test point or an easy test point might be test point 0. We can plug 0 into that first derivative. Plugging 0 into the first derivative, we have a negative 2 times 0, which is 0 plus 300. So we get 300, which is a positive value. So that tells us that our derivative is greater than 0 in this interval. So that means that the function is increasing. When the derivative is positive, the tangent lines to the curve are positive, so the function n of x is increasing. Next, we pick a test point out of the interval 150 to infinity. I'm going to choose 200 as a test value. If we plug 200 into the first derivative, we have a negative 2 times 200, which is a negative 400, plus 300, so we get a negative 100. So the derivative is negative. So n prime of x is less than 0 on this interval. So if the derivative is negative, the slope of the tangent lines to the curve are negative, so the function is decreasing. So since the function goes from increasing and then to decreasing, that indicates a maximum. So we have a relative maximum at the critical value x equal 150. To find out what the actual relative max value is, we need to plug 150 into the original function. When we plug 150 into the original function and simplify, we get 22,506. And in this case, in context of the problem, that would be units. So after spending thousands of dollars on advertising, this company estimates that it'll sell 22,506 units of a new toy. And that is the maximum. To graph this function, I'm going to show you how we can do this in the calculator. So we're going to hit our y equals, and then in our y1, we're going to type in a negative x squared plus 300x plus 6. Now if you try to hit graph, here's our standard viewing window from negative 10 to 10 along the x and y axis. So we don't see our function. So I'm going to go to my windows and I'm going to adjust our x and y axis so that we can see the function. Now we have to think about our function here. We are told that the x goes from 0 to 300. So we need to change our x min and our x max to be 0 to 300. And this makes some intuitive sense. We're talking, in context of the problem, we're talking about the amount of money spent on advertising in thousands of dollars. So perhaps this company, they've maxed out at say 300. That's kind of the maximum amount of money maybe they're going to spend on advertising. And then 0 makes sense since it doesn't make sense to have a negative amount on advertising. All right? And then if we look at our Y min and our Y max, well, in context of the problem, our output values, we're talking about the number of units sold of a new toy. So it doesn't make any sense to sell a 0 number. So we can change our Y min to be 0. And then our Y max. Well, we know, based on finding our relative extrema, that we had a maximum at 22,506 units. So our Y max should be set really large. For example, if we go with 23,000, we'll be able to capture that maximum extrema, that relative extrema. So now hit graph, and there is our parabola shape. So here's a graph of our function. And if we want to check our relative maximum up there, we can go to Second Calc, go down to Maximum, hit Enter. Right now we want to make sure our cursor is on the left side of our maximum. So I'm going to use my arrows to arrow over to the left, hit Enter. Now I'm going to use my arrows to arrow over to the right of the maximum, and then hit Enter. Hit Enter again so that it will guess. And there's our maximum. And x, it occurs when x is 150, and our maximum value is 22,506.